So hi, I am Om. In the last video, we have learned about Streamlit, like how to make an application with the help of Streamlit. We actually saw how to write the code in Python to build an application in Streamlit. We have built a basic application in Streamlit with the help of Streamlit components. So now we are continuing our this Gen AI series. So our next topic is roadmap to learn NLP. So basically, first we will see what is NLP and like how to use NLP and what topics come under the NLPs, right? So basically, NLP can come under two different domains. So the two different domains are NLP in machine learning, NLP in machine learning, and NLP in deep learning. In deep learning. So basically, first we are going to see NLP in machine learning. So we will see what is NLP in machine learning. NLP in machine learning. So basically in machine learning, we basically solve two types of problems. Here we solve two types of problems, and the two types of problems are, first one is the supervised learning, first one is supervised learning, and second one is unsupervised learning. So we can say like in supervised learning, what we can do is we label the data. So basically we give the data to the model which is labeled. For example, if there are 100 images, if there are 100 images and each image is labeled. For example, there is an image of dog and this dog image is labeled as dog, like this. And if there is another image named as cat and this image is also labeled as cat. So let's assume there are 100 such kind of images and we are giving this 100 kind of images to our machine learning model. So let's say this is our ML model and we are giving the 100 images to this. So in supervised learning, what happens is we give the image and or we can say that we give the question and answers both to our model. And now if and now how our model will predict, if we are going to give the another image which is 101th image now, and if this image is of dog and if we give this image to our machine learning model, our machine learning model will predict that this image is particularly of a dog. So in this way our supervised machine learning uh, behaves, right? So now in what happens in unsupervised machine learning, so in unsupervised machine learning, we basically in unsupervised machine learning we don't have a labeled data, we give a random data. We give a random data to the model. So let's say we are having a random data, for example dog, cat. So these are the images, basically dog, cat, monkey. So let's say there are 100 images and this is not a labeled data. Now in supervised learning we will give all this data to the machine learning model, and now our machine learning model will find the patterns between these particular data and then generate the output on its own. So basically we are not giving any kind of label to our data in unsupervised machine learning. So these are basically two types of machine learnings. One is the supervised and another is the unsupervised machine learning. So now in supervised machine learning, we basically have the two types of problem. In supervised machine learning, in supervised machine learning, supervised machine learning, we have two type of problems. Two type of problems. So the first problem is the classification problem. First one is the classification problem, and the second one is the regression problem. Second one is the regression problem. Don't worry, I'll tell you what is NLP and what is the definition of NLP. We will get into that. Just be with me now. So there are two types of basically problems which we solve under the supervised machine learning. So what is mean by classification problem? So classification problems means basically we can say that when we have to classify between the data. For example, we have to identify that is if the email is spam or ham. So these are the two categories. Spam is one category and ham is another category. So let's say we have an email and we have to identify that does is that email is in the spam category or is in the ham category. So for that we use the classification problem. And what is meant by the regression problem? Regression problems means basically which is having the continuous values. For example, the stock market data, every time the ticker price gets change of the every stock, so that comes under the regression problem. So in regression problem, we basically solve the continuous values of the data. So these are the two types of problems we solve under the supervised machine learning, right? So now let's say we have four different features. We have four different features, and the four different features are, let's say, just a minute. Four different features are, let's say, f1, f2, f3, f4. Now these features are usually called as independent features. These features are usually called as independent features. We can say that these are the independent features. Now similarly, we will also have our output feature, which is our dependent feature. Output feature is depend on this particular input feature, right? So now what's our main aim in supervised machine learning model is that with respect to these features, we will have a lot of data points, and in output it can be a classification problem or regression problem. So let's say we are having these features f1, f2, f3 and f4. So let's say we have having a data in this. We are having a data set for f1, f2, f3, f4, and or let me create here f1, f2, f3, f4, and here is our dependent feature. Now in this, or we can say that this is an output feature and this is our input feature, we can say, right? So we are having a lot of data here. We are having, let's say, data here for f1 feature, for f2 feature, for f3 feature, for f4 feature, and here we will get our dependent feature, right? So we will usually create a model and train the model on this particular data. We will create a model and we will train our model on this particular data. Then our model can give prediction, right? Basically we can say that these are our independent features and we are training our model with this particular data, and this output feature, we can say that this is the prediction, right? So let's see this with an with the help of example. So now let's say we'll take the example of spam classification only. We'll take the example of spam classification. So in this particular example, the email which we have is spam or not spam or ham. This is a classification problem that I have to solve, right? Now we have independent feature as email subject. Let's say we have independent feature as email subject. These are the independent feature like this, right? Like this means input feature, we can say. Email body, and we have output feature such as spam or not spam. Let's say spam or ham, we can say, right? So this is our input feature and this is our output feature, means we will train our model on this particular data. Let's say we are having a lot of emails. Let's say we are having a lot of emails, so we will give all that data to our model and our model will predict either that particular email is spam or ham. So that is what, that is our output feature, right? So let's say in the email subject we are getting data like billionaire, I don't know what is the spelling of billionaire, I guess this is correct. Then let's say in email body we are having you won a lottery, you won a lottery. So these are some kind of images, and in the output feature what we are expecting is it is a spam or not spam, right? So let's say we are getting the output as 1, which means that it is a spam, and if there is a 0, then we can say it is a ham, right? So in this way we can say that in the classification models we treat not in particularly classification model in every classification problem, but in every problem there are some independent features and there is dependent feature. So dependent feature we usually called it as output feature, and independent feature we usually called it as an independent feature, right? Now my entire data is text or sentences like this. So in this particular scenario it is not that easy for a model to understand, right? See what is happening here is we are just getting simple text here, right? We are getting billionaire, you won a lottery, but let's say this is in English. Now here NLP comes into the play. uh, keep keep your eyes on this now. Let's say this particularly is in English, right? But what if tomorrow I got a mail and that was into a Chinese language or in a Mandarin language, what we can say, I don't know, or in a Hindi language. So our machine is not that capable, our machine is not capable capable to understand these languages, English or Hindi. So here NLP comes into the picture, or the NLP comes into the play, right? So and there are a lot of examples actually. When we say Alexa, play this song, so Alexa don't understand Hindi or English, right? It is the play of NLP. Here NLP comes into the play, right? now i now I write this in English, tomorrow it will be in Chinese, etc. So model is not directly capable of understanding this particular text. So what should we do in this particular scenario? So we have techniques due to which we can convert this text into a meaningful vectors. So what is vectors now? Vectors are basically a mathematical representation. You can consider the vector as, let's say, there is a word called the, and let's say this the is written into this format, 00110, let's say, right? So this is written into this format, so we can consider this as a vector. So basically this particular text is converted into a meaningful vector. I'll write here again. Text is converted into a meaningful vector, to a meaningful vector, right? Because our machine don't understand English, Hindi and all. Our machine can understand zeros and ones. Our machine can understand zeros and ones. So we convert our text into a vector format, which is basically a meaningful mathematical representation of data, you can say, in a simple term. So whenever you input, when your input data is in a form of text or sentences, we basically use NLP so that we will be able to process this particular data. We will be able to make model understand to solve use cases like spam classification, right? So now next time when you will get a lot of data, right, we will first convert that data into a vectors, and that vector is nothing but the meaningful representation of a text into a mathematical format. That's it, right? I hope you got until now. Now we will see now we will see how actually we will learn about the NLP. So what is the roadmap for NLP, right? So basically in step 1 we learn about text pre-processing. We learn about text pre-processing. We learn about text pre-processing. So whenever we have some text, what are the text pre-processing things we need to do, how basically we can clean that data, all those things come into the text pre-processing. So the techniques which we are going to apply in this is tokenization. So what is tokenization now? Tokenization is a concept where you convert a paragraph into sentences, sentences into words, etc., right? And finally at the very end you convert that words also into a vector, right? So in step 1, what we are going to do is text pre-processing. So this is the step 1. Now in step 2, what we are going to do, again we are going to do text processing only, text processing, text pre-processing only, right? And we can give it a name as text pre-processing 2. So here we focus on converting text data into vectors. In this particular step we will focus on converting text data into vectors, into the vector representation. Basically we can say into the mathematical representation, which is the meaningful mathematical representation for a particular word, right? So to convert the words into vectors there are a lot of techniques. So some of the techniques which we are going to use, or which we are going to learn is, first one is the one hot encoding. No one is using this right now, and this is the pretty old technique, right? One hot encoding. Then another type of technique is bag of words. Bag of words, we also write it as BOW, bag of words. Third technique is TF-IDF. TF-IDF. The fourth technique is word to vec. Word to vec. This is pretty advanced technique. And there is also another technique which is called as average word to vec. Average word to vec. But to understand these two are the mostly used basically techniques to convert the text into vectors. But we will look into all the techniques. But for these particular two techniques you will need to have some understanding of ANN, or the deep learning as well. So we will see how these particular techniques work. So these are basically, this happens into the step 2. We will convert our text into vectors, right? Now in step 3 again happens is text pre-processing, and we'll give it a name as text pre-processing 3, let's say. Now in this we use more advanced techniques like word to vec, average word to vec. This is also a technique to convert the input text into a vectors, right? So in this particular step, what we are going to do is we are going to basically see these two particular techniques, right? Word to vec and average word to vec. Now in step 4 what we are going to do is we are going to understanding RNN, LSTM RNN, GRURNN, right? So we are going to see in this particular neural networks into the detail. uh, yeah, that's it. In step 5 what we are going to do is in step 5 we are going to learn about the transformers, like how transformers basically use. We will also take the lot of examples like NLP with the help of transformers. We will see how NLP works with the help of transformers, natural language processing in transfer with transformers, basically NLP with transformers. We'll see a lot of examples into this also. Now in step 6 we are using BERT. We'll see what is BERT and a lot, right? So as we are learning this from machine learning perspective, so we will focus on step 1, step 2 and step 3 first, right? As we are learning from the machine learning perspective, we are going to focus on step 1, step 2 and step 3 first. So these are the very basic steps, and these are the very easy techniques that is basically which will help us to convert our text into the meaningful vectors, and we will see like how it works, and we will see in detail that also we will see the also we will do the practical, like how actually we can write a code and convert our text into a meaningful vectors, right? So to do that into the practical, I'm just giving you some idea that we are going to use the libraries like NLTK, and there is also one library called Spacey, but mostly we will use the NLTK only. NLTK is the best library to use all these functionalities, right? So now we will see the what are the practical use cases of NLP. Basically, practical use cases of NLP is nothing but the Alexa, your Alexa system, right? Your Alexa is there. Then Google Translate is there. Google Translate, like when you open the Google Translate, you just select one language as English and convert that language into the Hindi, and this will be done into the real time. In the real time, when you are writing, "Hi, I am Om," so in Hindi, yeah, here you'll get "Hi, मैं ओम हूँ, मैं ओम हूँ." I guess as it in this way we write this only, I guess. So these are the basically some of the example. Also there is you use LinkedIn, right? So in LinkedIn as well, when you do when you message someone personally, you will get auto recommendation for that. Or on the Instagram, when you if someone wrote the comment in Hindi or Sanskrit, Hindi or Sanskrit, you will get the option of their C translation. So when you click on C translation, it will get translated into English. So these are basically some of the example of the like these are the some practical use cases of NLP. Right, now we will see the tokenization and basic terminologies. We'll see tokenization, and basic terminologies. So, basic terminologies are basically what we can say is there is some words like corpus. So, what is meant by corpus? A paragraph. Basically, a paragraph. A big paragraph, let's say. A big paragraph is known as the corpus. A big paragraph, right, is known as the corpus. Now the another is documents. We will see this in detail, don't worry. Documents, what are documents? Documents are basically sentences. Then we have vocabulary. Vocab, very important. This is very important. Vocabulary is very important. See all the unique words, all the unique words present in corpus. With the help of vocab only, we are going to convert the text into vectors, right? So vocabulary is very important. Then there is a word. So what is meant by word? All the words which are present in the corpus, basically all the words which are present in a corpus. So these are some of the basic terminologies which we are going to use into our course, right? Or this is used worldwide, right? Now, what exactly is tokenization? So we will see what is tokenization. So tokenizations means basically, let's say we have a big paragraph. Let's say we have a big paragraph. So what tokenization does is we we break down this paragraph. We break down this paragraph. We break down this paragraph into sentences. We break down this paragraph into sentences, right? Now, what we do, we also break down the sentences into words. Sentences into words. We will see in detail like how we do that, how we actually do that. We will see all this in the practical, right? So let's say I'm having like one paragraph. Let's take an example. Let's take an example as my name is Om. My name is Om. Uh, I'm learning Gen AI. I have interest in machine learning and Gen AI. Let's say I have this particular paragraph, right? So now we can say this as our corpus. Now what tokenization do is tokenization search for the special characters. For example, this full stop. The tokenization search for the special characters like full stop, exclamation mark, comma, everything. Now what tokenization will do is it will break down this particular paragraph into sentences. So so it founds that here it is a comma. So now it will convert this paragraph into two sentences. So the sentence one will be, my name is Om. I am learning Gen AI, right? And the sentence two will be, I have interest in machine learning and Gen AI. So we convert this particular paragraph into sentences, into sentences, into two different sentences. Now, now what we are going to do is what we done until now is we search for the full stop, we search for the exclamation mark, we search for the comma, and with the help of these special characters we broke down our sentence, we broke down our corpus or the paragraph into our sentences, right? Now what we are going to do is we will perform another tokenization on this particular sentences. Now we will perform tokenization on this sentences. Tokenization tokenization on the sentences. So when we perform the tokenization into the onto the sentences, what we are going to do is we are basically going to find out the words, right? So we are going to find out the words. So there are a lot of words. So basically now let's say we have to find out the vocab. So to find out the vocab, we will look for the unique words. For example, my name, Om, learning Gen AI. Then have, interested, machine learning, Gen AI. So basically these are the unique words, and we consider these words in I am, I, is as a stop word. Basically stop word means I am, in, the, and these kind of words are considered as the stop words. So basically if we look for the vocab in this, if we look for the vocab in this particular sentences, then we'll have my name, Om, learning Gen AI, have interest, machine learning, Gen AI. Not Gen AI once again, not Gen AI here, because we already write Gen AI here, and as we know, the vocabulary are the unique words, right? So in this way we can perform tokenization. So again, to explain the tokenization, what we did is, we have a big corpus, and from that big corpus we search for, when we apply tokenization on that big corpus, we search for the special characters, for example comma, exclamation mark, full stop, and then we when we apply the tokenization on that particular that particular corpus, we convert that corpus into sentences, and on performing tokenization onto the sentences, we get vocab, right? And now from this vocab we are going to convert our text into, now from here, we are going to convert our this text into meaningful vectors, right? So there are a lot of things to learn now. So we will see like how to apply the analytical libraries, to find out the vectors of this particular vocab. So we will use, firstly we will see the one hot encoding. After that we will see a lot of techniques, like bag of words, TF-IDF, and everything. We will see like how to convert words into vectors. So basically this is the end of this video. From the next video we will see the tokenization practicals. We will see some like how to do tokenization in the real life or onto a real data. And yes, that's it. I'll see you in the next lecture.